Sasrikal. Today we are going to be talking about, once again, applying quadratics. This time we're going to talk about motion. Make sure you have this handout before you begin, so that way you don't have to write all this. Alright, so vertical motion, we're given two formulas. If you throw something into the air, say you're throwing a tennis ball, hopefully not throwing a person, not throwing calculators. This is the two equations we could use. Here's the big difference between them. This first one is in feet. So we have d equals negative 16 t squared plus vt plus h. Notice v is the velocity, which is a fancy way of saying speed. Don't tell any physics teachers I said that. Technically velocity is a little different, but when you get to physics, you'll talk about that. And the initial height is h, or beginning at height h. And then the only difference here is our coefficient for t squared, and this is what we use for meters. So all that changes is our number in front of t squared. So we're going to solve some word problems. But before we do, I realized we need to review something. So we did this with linear equations last semester, but I think we may have forgotten a bit. If I give you f of x, remember that's how this is read, f of x equals negative 1/2 x squared plus 20x plus 100, we want to know the value of f of 8. So here's what I point out. This looks an awful lot like that, but instead of an x, we have an 8. So that means we're going to take this equation, anywhere we have an x, we're going to put an 8. So we have negative 1/2, use parentheses. Anywhere you have a variable, replace it with parentheses. So 1/2 x squared plus 20x plus 100. That's our equation. And now we said we want to find it for 8, so we plug in 8 here and here. And you have a choice. You can solve this by hand, or we can be lazy. Plug this into your calculator, exactly this, parentheses and all, and guess what? You'll find out that this equals 292. And that is f of 8. So just a little reminder, don't get freaked out if you see this on, a quiz or test. Just notice the 8 replace the x. So it's telling us what to do. Replace the x with 8. That's all. All right. Let's look at these word problems. These are crazy. Okay, we are in a helicopter. Woo! We're going to release a package at 1,600 feet. We're given this crazy equation, and please notice over here there's a negative sign, so you might want to rewrite it over here. H equals negative 16t squared plus 1,600. H is the height of the package in feet, t is the time in seconds. We want to know how long it'll take to hit the ground. Let's make a little drawing of this. So, like a graph. So this is feet. Oops, you can't see that. Feet. This is seconds. So our package starts here and goes woo. Hopefully it doesn't break. So they tell us it starts at 1,600 feet. So this is 1,600 feet, and this is where it ends. And here's what I want to point out. This is the ground right here. That's the ground. Ground. Whee. And guess what? What height is the ground at? Well, the ground is at 0. 0 feet, right? So that means our distance, we go back to the top, looking, distance, or height as they gave us, our height equals 0. And you know what? I bet you we can solve this from here. So this is really our equation. I like red better. Let's stick with red. Okay, so h is 0 equals negative 16t squared plus 1,600. And you know what? I'm going to use a capital T because I just realized my t's look like plus signs. So you might want to do that too. Okay. And you know what? I'm going to pause and point out this is a quadratic, right? Because we have t squared. But notice we don't have a b value. We have a x squared, t squared, same thing. But no b. We don't have a t by itself is what I'm trying to point out. So make a little note. No t. There's no t by itself. So that means we can use that square root trick. Because if I can use a shortcut, I'm going to use it. Remember the first step of the square root trick, we got to get our ax squared on one side and our c on the other. So the easiest way to do this would be, we need to add or subtract something both sides. I'm going to add 16t squared to both sides of my equal sign. Okay, that gives me 16t squared on the left. This cancels. So we just get 1,600. Okay, step 2 of solving by square root. is we need to divide by a. A is the coefficient of t squared, which here is 16, so divide both sides of your equal sign by 16. We get t squared equals 100. And the last step, take the square root of both sides. And remember, taking the square root of t squared, x squared, whatever, cancels out. We just get t equals, and here's the thing everyone seems to forget. When you take the square root, it's plus or minus your answer. Square root of 100 is 10. So let's pause and think a moment. We know when the package hits the ground. It only hits the ground once. We got two answers. We got t, so I'm going to write this to the side. We got t equals negative 10 and t equals positive 10. So let's think about this. We're talking about how long it'll take the package to hit the ground. Does it make sense to say it'll take negative 10 seconds? Heck no, that's crazy. But hey, it does make sense to say it'll take positive 10 seconds. So it will take 10 seconds to hit the ground. Yay! We got our first problem done. Alright, let's move on to the second one. We are given a flare fired from a ship, and here's our equation. So let's make a little picture. Again, we're in feet, and here's seconds. And when you shoot off a flare, it's going to go woo, like that. And we're told it starts at 56. So remember, this number tells us where we started. We started at 56 feet. And again, we want to know when it hits the water. Well, if we're in a ship, the water is at height of 0. So it's going to be really similar to before. We're going to have 0 equal to our equation. So I'm just going to copy down the equation. And we need to solve it. But notice we do have a t, so we cannot use the square root trick. Instead, we got to use the quadratic formula. So that means we need to know what a, b, and c are. A is our coefficient for t squared, which is negative 16. B is our coefficient for t, which is 104. And c is our number without any variable, which is 56. All right, let's plug it in. So t, because we're using t instead of x, equals, and remember, do your skeleton first, negative b plus or minus the square root of b squared minus 4ac all over 2a. Remember, always draw your skeleton if you're using the quadratic formula. Now fill it in. We need a b here, b here, a here, c, and a once again. So t equals, that's negative 104. Now we're having some troubles putting this in the calculator. I'm just going to I'll show you what I'm putting in the calculator. Just this. I'm not going to do the square root because that seems to be messing some of us up. So I'm just going to put that in. So nothing happened to my plus or minus, nothing happened to my square root, and don't forget to use parentheses when you put it in. You should get 14400. And that's 2 times negative 16 is negative 32. Okay, now we need to break it into two different problems. One of them is negative 104 plus the square root of 14,400. All over negative 32. That's one problem. The other solution we have is negative 104 minus the square root of 14,400. And that's all over negative 32. And please be careful when you put it in your calculator. For example, here type negative 104 plus square root of 14,400. Hit enter, then divide by negative 32. When you do that, you should get t equals negative 1/2. And if you have problems putting that in your calculator, please just ask. I'll be more than happy to double check if what you wrote is what you actually put in the calculator. So that's one of our answers. Our other answer, when we put negative 104 minus the square root of 14,400, hit enter, then divide by -32, we get t equals 7. So ask yourself, do both of these answers make sense? No, we can't have a time of -1/2. That makes no sense. So here's our real answer. So time it takes the flare to hit the water, it hits the water at 7 seconds. Cool. Let's go on to the back. This last one is really complicated, so I know this video is getting long, and I really appreciate y'all following along because it is tough, but I know you can do it. Okay, we have a model rocket, super, and it starts at 100 meters. Notice that's important. Shot in the air with initial velocity of 102 meters per second, and we want it to know, will it reach a height of 600 meters, and if so, when? Again, I like to draw pictures, helps me visualize this. So this is what a graph of it would look like. So you shoot the rocket, we start at 100 meters. You go, pew, and it comes back down. Goes something like that. So this is 100. And remember, this is meters, and this is seconds. All right, so here's the thing. It did not give us a formula, so let's look back at the front of our paper. Since we're using meters, we need to use this formula. D equals -5 t squared plus v is the initial velocity. Initial velocity is 102, so 102 t plus the initial height. Initial height is 100. All right. So let's see if we can get this figured out. Now, we want to know about a height of 600 meters. So that means our distance up is 600. So I'm going to rewrite it, but with d equal to 600. Awesome. This is almost in standard form, but notice standard form has to equal 0. So we need to subtract 600 from both sides. And notice 600 does not have a t squared, so don't combine it with this term. It does not have a t, so don't combine it with this term. It's all by itself. So we're going to subtract 600 over here. We get 0 equals -5 t squared plus 102 t minus 500. Cool. Let's label A, B, and C. A equals -5. B equals 102. C equals -500. Okay, put in your equation. T equals negative b plus or minus square root b squared minus 4ac all over 2a. Plug in your numbers. And let's simplify a bit. That's a -102 plus or minus. And again, I'm just going to put this in my calculator. Watch your signs. That might mess you up. Watch your signs. We get the square root of 404 all over -10. Let's break this into two problems. Oh, just realized you can't see that. Sorry. That's a -500 over there. Okay, we have -102 plus square root of 404 over -10. And then we get -102 minus the square root of 404 all over -10. Okay, again, do your numerator, then do the denominator. You end up with t is approximately 8.19 seconds here. And t is approximately 12.21 seconds. And I want to point out, these are both positive. These both make sense. Let's look back at our graph to see what that means. So we were talking about distance of 600 meters. Let's say right here is 600. That means going up, it hits 600 meters there. Then it reaches the arc and it comes back down and it goes all the way down to the ground. So that's why we have two numbers that make sense. Is on its way up, it hits 600 meters, it goes a little higher than that, and on its way down it hits 600 meters before hitting the ground. So that might help you. That first number, that lower number, 8.19, is smaller. That's on its way up. And then the bigger number, later in time, is when it's coming down. All right, I know this is really long. Thank you for being so patient. You have some homework, well, hopefully we'll do it most in class. Get to that. Let me know where you're confused, where you're stuck. I'm here to help.